Alright, we need to match each graph with its domain and range. So, here we go. Number one is a parabola, which means it goes left and right forever, so the domain should be all real numbers, but all of those answer choices have that, so that's not really going to help. So we need to look at the range. This graph has a lowest value that appears to be, I don't know, 3 or 4 somewhere in there, and if you look, that's kind of what we have right here. All real numbers greater than or equal to 4, so I feel like that matches up okay, at least temporarily. Number 2, we have another parabola with its vertex is a little bit lower. It goes to, I don't know, 1 right in there, so 1 or 2. And so we have that answer right down here, all real numbers greater than or equal to 1, so I feel like that's letter E. Number 3 is a straight line. Those go left and right forever and also up and down forever, so that's going to be all real numbers, and that would be what B says. Number 4 has a highest point. It goes up to 1 and then goes below that, so that's actually what A is saying. If you look at it, that says all real numbers less than or equal to 1. And finally, number 5, process of elimination. But this graph is getting really close to 0, but never quite touches it, or I'm just noticing that's actually then a typo on letter D. It shouldn't be or equal to. I feel like here we go. Okay, now we need to use the quadratic formula to find the roots of that function. So let's begin by listing out our A, B, and C. So I think A is 2, B is 6, and C is 4. So let's plug those into the quadratic formula. So opposite of B would be negative 6 plus or minus square root of B squared minus 4 times A times C, all over 2 times A, which would be over 4. Now we just have some simplifying to do underneath that square root. Let's see, 6 squared, go off to the side here, so I'm working on the inside. 6 squared minus 4 times 2 times 4. So that's 36. 4 times 2 times 4, that's going to be 32, which is 4. So I'm looking at plus or minus the square root of 4. But square root of 4, that's just 2. All over 4. So let's do that math. Now remember, we've got this plus or minus sign to deal with, so that means we need to do negative 6 plus 2 divided by 4. That's going to give me an answer. And also negative 6 minus 2 over 4. That's going to give me the other answer. Negative 6 plus 2 would be negative 4 divided by 4 would be negative 1. And our other answer, negative 6 minus 2, would be negative 8. Divided by 4 would be negative 2. So the answers were negative 1 and negative 2. Number 7, use the graph to complete the table. That must have went with this next question. Alright, so here we go. Standard form, A is 2, B is negative 12. Didn't write that very well. And C is 10. The y-intercept would be the number 10, which is the same as the C number. Now that we have that, we should be able to sort of figure out what the vertex is. Now the vertex is this point right down here. And it's not too hard to look at the graph and sort of be able to tell what that is. I feel like I'm going over 1, 2, 3 and down 1, 2, 3, 4, 5, 6, 7, 8. I feel like that's the point 3, negative 8. So I'm going to put that. Sometimes it's a little tough to tell what the vertex is, but I feel like I could count that pretty well, so I'm pretty confident there. The vertex form uses the vertex, so the vertex form is the A number, which is 2, times x minus the x value of the vertex, which is 3, so I'm going to put x minus 3 squared, and then the y value of the vertex just goes outside there like that. So that's vertex form. The roots of this function are 1, that's this point is 1, and this point over here is 1, 2, 3, 4, 5, which allows me to write factored form. Factored form takes the roots and puts them like this. So if the root is 1, then I put minus 1. If the root is 5, I put minus 5. Remember, the order there doesn't matter. This problem, I left out a picture, so you could just cancel this out. But if the picture had been there, it showed a triangular garden, and in this triangle it wanted there to be one of the sides be 4, the other side be 5, and the other side be 6 feet long. And so if you read the question now, it makes a little bit more sense. Among the following lengths in inches or of pieces of lumber, which is the shortest piece that he can cut? Well, each cut takes 1/8 of an inch of wood off of there. So if you think about a really long board, and we're going to cut that into 3 pieces, each one of those little cut marks takes away 1/8 of an inch, which is not very much, but add them up together, and that's 1/4 of an inch that we need to consider. So, and then from there we've got these feet. Now these answers over here are in inches. So we need to convert our feet. So 4 feet plus 6 feet plus 5 feet is 15 feet. But if I take 15 feet times 12 inches to convert, 15 times 12 is 180. So that makes you feel like you should circle C. However, don't forget about this 1/4 of an inch. That 1/4 of an inch needs to be added on to it, which gives you 180 and I guess a fourth. But that means the shortest piece that we can use to cut that would be D. That's the answer. Kind of a weird problem. In the figure below, A, B, C, D are collinear. That means they're on the same line together. FC is parallel to ED, which means I can add these little marks from geometry where we put like a little arrowhead on those to say that those are going in the same direction. They're parallel. And our job is to find the measure of angle FCB. So here we go. So in my mind, we're really working with 2 separate triangles. I know they're just sort of overlapping, but we know that this guy is 63 degrees. And then we have this other triangle, and all we know is that that one's 90. Well, or it's a right angle, which means it's 90. Remember that the 3 angles of a triangle add up to 180, so that's where we're going to kind of get some of these. Now we have this 147 right here. Well, that doesn't mean, I mean, that's this angle, which is not really a part of my triangles, but if you think about this little angle next to it, which happens to be this angle, you would do 180 minus 147, which would be 33 degrees. And that would allow us to find the third angle over here, because they have to add up to 180. So it's kind of like if you take 180 minus the 90 and minus the 33, that gives us 90 minus 33, which is 57 degrees. That would give you this angle. Now, how does that help us? Well, because those are parallel lines, that makes this angle and this angle congruent, because they are what we would call in the world of parallel lines cut by a transversal. They are corresponding angles, I believe they're called. So either way, the answer is B. Done with homework. Good job.